Alright, 8th grade honors class, we're doing Pythagorean theorem. We're going to start off with a triangle. Here's a right triangle. The reason why you know it's a right triangle is because it has a right angle symbol right there. Imagine that. So, here are the components of the right triangle. We have two legs, A and B. B usually means base, A means, I don't know, altitude, I don't know what it really stands for. And C stands for a hypotenuse. Now, sorry about that, announcement came on. So we have legs, and it doesn't really matter if the legs have A and B. They could be the reverse, B and A. The one that really matters is this C right here, because it's a hypotenuse. It has to be across from the right triangle, and it is the longest side of the triangle. Doesn't matter what B is, doesn't matter what A is. If it's a right triangle, C is always the longest side. So here's the three squares that make up a right triangle in the middle. And Pythagoras, I'm guessing, saw this pattern, and he decided to make a theorem out of it to see if it worked on everything else. And it did, so now we have Pythagorean theorem. Basically what he saw was if he took the area of this box and added it to the area of this box, then he would get the area of this box, which is crazy. But the reason why it works the way it does is because it has to form a right triangle in the middle. Now let's look at this a little bit closer. Here's three boxes just like before, and we have a right triangle in the middle right there. Now if you notice, on the smaller boxes, every side of these boxes are 5. So they're not just boxes, they're squares. They have to be squares. They have to be equal. And you notice the 25 that's in the middle of them is the area of each one of those. So based on his theorem, A plus B equals C. So the area of A, let's call this one A, is 25. And the area of B, let's call this one B, is 25. So if we add those together, we should get the area of this one, C, which is 50. Let's make it better, 50. 50. Now, you can actually check it out, or you can take my word for it, but if you count every square in there, you get 50 squares. If you want to, let me save you some time. You see the little green marks right here? Right there? That represents 4 squares. So there's 5 of those 4 squares, so 5 times 4 is 20. And then if you look at the red ones right here, those represent 5 squares, and there's 4 of those, which makes 22. Not 22, but 20 also. And then the little blue dots, those represent half squares, and there's 20 of those. So, but if they represent half squares, then that means there's really only 10 boxes. So if you count them all up, it ends up being 50. So it actually works out, which is crazy. Crazy. So, what you really want to realize is that this works. And it's the area of one box plus the area of the other box equals the area of the last box, of the hypotenuse. So, how do they make it into actual Pythagorean theorem? This is how. We know that the area of A is formed by its sides. Taking little a times little a, which is this, a squared. And then area of the B box is formed by little b times little b, the sides. And that should equal the area of C, which is also C times C. Like that. And that's how they get Pythagorean theorem. That's it. So here's an example. I'm going to do it 2 ways. I'm going to use the box method. Well, not really the box method, but using the boxes to show you how to do it, and then I'm going to use Pythagorean theorem the same way. So let me show you. what we figured out before, we want to find C. It's right here. So what we did before is we made a box, and here's another box, and here's another box. We know that the area of this one plus the area of this one gives me this one. So let's label this A and this B. This has to be C. Already done. So if the sides of this one are all 5, then the area of it is 25. And if all the sides on this one are 12, then the area of it is 144. Alright, so, sorry I got interrupted again. So we found the area of both those boxes. So to find C, we have to add A plus B. So 25 plus 144 is 169. Now, that's the area of the box. That's not what C is, because C, lowercase c, is what we're looking for. We're looking for that side. So to find 169, the side of 169, or the root of 169, we do the square root, which will give you 13. And that's it. So let's try it a different way. Now we're going to actually use Pythagorean theorem. Here's Pythagorean theorem. A squared plus b squared equals c squared. So let's plug it in. First we have to label what A is. Here's A. Now we have to label what B is. Here's B. We already know what C is because it's across from the 90-degree angle. So we're good. And it's already labeled for us. So now we plug it in. 5 squared plus 12 squared equals c squared. See, it's the same thing we did before, it's just without all the pictures. 5 squared is 25. 12 squared is 144. And that equals c squared. So 25 plus 144 is 169. That equals c squared. Now here's a deal that kind of people get confused about. This is c squared, which means this is the area of that box, because c squared means side times side. So if we want to figure out what just one single side is, we have to take the square root of it, which gives us 13. And we're done. Let's do another example. Here's another example. We're trying to find A. So let's try it out. Here's my A. Here's B. And here's C. So let's plug it in the formula. A squared, which we don't know, plus B squared, so 4 squared, equals C squared, or in this case 5 squared. A squared plus 16 equals 25. Now, if you remember solving one-step equations, what you do to get the 16 on the other side is by subtracting 16 on this side, because 16 minus 16 equals 0. So you subtract 16 on this side. And we get A squared is equal to, what do you think? 9. Now A squared is the area and 9 is the area. So if we want to just find A, we have to take the square root of 9, which is 3. And 3 is our answer. In fact, this is one of the most popular triangles. It's called a 3, 4, 5 triangle. It's one of the only ones that does that. Alright, so you saw that how we had to solve for certain letters. Well, let me go ahead and do that for you. This is how we solve for the letters. Let's solve for A. What is A? Well, how we did A is we subtracted the B squared from both sides. And what that did for us is we got A squared equals C squared minus B squared. Now we can't subtract these two because they're not like terms, if you remember that from last year. And then what we did was this is what this area equals, so we had to take the square root of it. So when we're done, we end up getting A is equal to the square root of C squared minus B squared. Now let's do this again. And let's find B. I'm going to guess it's the same thing, but instead of B squared being right here, we're going to have A squared. Let's check it out. Subtract A squared from both sides, and we get B squared equals C squared minus A squared. Then we take the square root of both sides, so we get B is equal to C squared minus A squared. That easy. Now I'll save C for last because it's the easiest. C doesn't move. You're done right there. But if we want to find what a single C is, we have to take the square root of both sides. So that's the only thing that's left to do. So C is actually equal to square root of A squared plus B squared. Now we'll talk more about this in class. And that's pretty much all she wrote. Actually, I guess I'm a he, so all he wrote. Mr. Naval. He's awesome. He can draw smiley faces on YouTube. That's right. Remember that.